Hey, good morning, everybody. Let's greet each other properly in here. Good morning. This is Mr. Aynesworth, and I'm here at Great Oak High School here in financial algebra, and we are in Chapter 2, Section 3, and we're going to get started talking about the savings accounts. We're going to use Desmos, all right, but we're going to be talking about the savings account. So, speaking of Desmos here, let's go ahead and let's start up and go ahead and obviously log into your account. Okay, click on the save button and change the title to 2.3. All right, we're going to be talking about savings accounts. So type in that first. Let's get started here. Savings accounts. All right, followed by your name. Okay, I'm going to put mine. You put yours. All right, that way when you print it to a PDF and put it in Canvas, it's all ready. You guys know how to do that if you're working with me. I've done that many times with you guys. So do all your work in Desmos here, save it all. That validates all your work. Okay, so, and also you're probably going to be able to fit all your work here in the workbook. So I'm just open this up, make it a little bit bigger here. Let's get started. Okay, so here we go. Let's talk about some savings accounts. And so we're going to be using one main concept in here throughout the savings accounts. These are simple interest accounts, and simple interest accounts, the interest is calculated the same way all the time. So these are what are called simple interest accounts. So let's write that down. So simple interest account. And then when you calculate interest, and if it's simple interest, not compound interest, that's later on, but when you're calculating simple interest, you're going to be using this same formula every single time. And interest is always calculated by taking the principal, which is your starting amount, all right, the principal in dollars, multiplied by the interest rate. Okay, so your interest rate, all right, multiplied by the time in years. So time in years. And we abbreviate that as I is equal to P times R times T, where R stands for the rate, T stands for the time in years, and P stands for the principal. So we're going to be using these abbreviations, P, R, T. Okay, so I is equal to PRT. So let's write that down in the margin here, and just as an abbreviation. So I is equal to principal times rate times time. Okay, that's how simple interest is calculated, not compound interest, but simple interest, like in a savings account, let's say. So let's go through a series of problems here. I'm going to work through 1 through 9 with you, and you guys can do the rest, and then we can follow up in class if you guys need more help. Okay, so I is equal to PRT. Let me write it down here actually so I can expand this here. Here we go. Number 1, Gary deposits $3,700 into an account that pays 2.15% simple interest. Notice the word simple interest. That's important. And so already I know, let's write down what we know. I know the principal in the account P is $3,700. I know that the interest rate R is 2.15%. 2.15%. All right, and when you change a percent to a decimal, you simply divide it by 100, because percent means per 100. So and that's just going to shift the decimal left 2 places. So when you do this, when you take 2.15%, change it to a decimal, you divide it by 100, you shift the decimal left 2 places, and notice you get 0.0215. So this is equal to 0.0215. You simply divide the interest rate by 100 to go to decimal, and you're going to have to do that all the time. Okay, you'll see me do that all the time as well. He keeps all the money in the account for 3 years, so there's your time in years. So T is equal to 3 years. Make sure that you understand that T is in years, not in months, but in years, always for this. So whenever you're using simple interest formula, which is this equation right here, I is equal to PRT, interest equals principal times rate times time, T has to be in years. Very, very, muy importante. Okay. The question is, and it reads on, if he keeps it in there for 3 years but doesn't make any deposits or withdrawals. So he just puts it in the account, lets it sit for 3 years. The question is, how much interest will he receive after 3 years? So let's calculate it. Very simple. So I is equal to P, all right, $3,700, this is a dollar amount, times the rate, 0.0215, times the time in years, which happens to be 3 years. And all you do is enter that in Desmos and then let it do its work. All right, so 3,700 times 0.0215 times 3. Simple. And you get $238.65, so $238.65. That's the interest that he has in the account, not the overall balance, but the interest only. Okay? You'd have to add the interest to the original principal to see how much money is actually in the account. But it wasn't asking that. It says how much interest will there be. So you got to focus in on the question here. The question again is like, how much interest will he receive after the 3 years? Well, guess what? Okay, it's $238.65. All right, number 2. How much will be earned on $6,000? So the principal there is $6,000 at an interest rate of 2.25%. So R is 2.25%. So that's 0.0225 as a decimal in 4.5 years. So T is equal to 4 years. So you notice how I'm always writing down what I know. All right, and you should do that too. Always write down what you know, and then you obviously figure out what you don't know, right? And we don't know the interest. That's what we want to find. How much simple interest would he earn? So here we go. So $6,000 times 0.0225 times 4 this time. And what will that give us? I don't know. Let's figure it out. So we have $6,000 times the new interest rate times 4. All right, notice that's 500. Whoops, not times 4. Let me read. 4.5 years. Sorry, let me back up. 4.5 years. Sorry, so let me change this over here. The time is not 4. I misread it. 4.5 years. So T is equal to 4.5 years, not 4 years. So that's going to change my number here. But in Desmos, it's easy. You just change your number, and the result automatically changes. And that's why I like using Desmos, because you can see the setup right here. As you can see, you can see everything. You can see the setup and the results. And that's why I teach with Desmos versus a traditional calculator, because you can't see the setup. So how you type it in is called the setup. And you get $607.50. That's the interest only, okay? Number 3, how much principal would you have to deposit to earn $700 simple interest in 1.5 years at a rate of 2%? What would the principal have to be? So here, you don't know what the principal is. You got to find P. All right, the principal. You don't know what it is, so you got to find it. All right, but we do know some other things. So I here, I is 700. R, the interest rate, is 2%. So 2% as a decimal is 0.02. And then T is 1.5. So T is equal to 1.5 years. So what we're going to do is I'm going to write down the equation first. So I is equal to P times R times T. And you substitute your values in now. We know the interest is 700. We don't know the principal. We do know the rate, though, which is 0.02. And we do know the time, which is 1.5. So what I'm going to do is I'm going to go off here to the side. I'm going to simplify this a little bit. I'm going to multiply 0.02 times 1.5. And notice I get 0.03. So I'm going to simplify the equation a little bit here. I'm going to write it as 700 is equal to P times the 0.03. Divide by 0.03 to solve for P. So you just take 700. All right, and divide it by your decimal, and you get about, whoa, look at this, 23,333.33. And by the way, always round your money to the nearest penny, which is the nearest hundredth. So $23,333.33. Always round it to the nearest hundred. Okay, so yeah, there we go. So that's number 3. Okay, so like I said earlier, if you can't fit all your work in your workbook here, get out your spiral and do your work in your spiral if you want. Do your work in your spiral if you have big handwriting, okay? And because you're going to have to submit this, okay, into Canvas here. I will not accept a workbook with just answers on. If you don't show setup, let me write that down up here. You have to show setup and process, because if you don't, I'm not going to give you credit for your work, because I publish the answers in Canvas, as you guys know. So show setup and process for any credit. Okay, that's standard in my class, and you guys know that. Okay, next one. Number 4, Jesse estimates that it will cost $300,000 to send his newborn son to private college in 18 years. He currently has $65,000 to deposit in the account. What simple interest rate would he need so that $65,000 will grow to $300,000 in 18 years? Interesting question. All right, because private college is expensive. You know, it's like, in this case, it's like $70,000 to go. Over $70,000, $75,000 to go to this private college, you know, if he goes there for 4 years. $75,000 a year. I mean, that's a lot. But so currently he has 60 right here. He currently has 65,000. There's your principal. So 65,000. All right. And what would the interest rate be to get to 300,000 then? Wow. Okay, so how are we going to do this? Okay, so first of all, we want to go from 65. I'm going to take back what I just said earlier. That's not the principal. That's just the original amount. We want 65,000 to get to 300,000. So what would he have to make in addition to the 65,000? Well, let's figure that out. Let's subtract the two. All right, so 300,000. Let's type that in, subtract the 65,000, and notice that he needs another $235,000 in the 18 years to make this happen. So let me just keep my work over here. So we need an additional $235,000 to make that happen in 18 years. And that's the interest, okay? That's the interest that we would have to make. So this actually is the interest. Now the time is 18 years. We know that's T. We don't know R. We got to find the interest rate. It says right here, what simple interest rate would he need? All right, well, we don't know R, so guess what? R is equal to some unknown. So it sounds like we got to solve for R. So we do know the time is 18 years. We know T is 18. Okay, 18 years because it says so in the problem. And we know the original principal was 65,000. So what I said earlier is actually okay. So here we go. I'm going to write out the equation first. You know, I'm going to do it off to the side too, down here. Okay, so I is equal to principal times rate times time. So the interest that we need is 235,000. The principal that we start with is 65,000. The interest rate is unknown, and the time is known. The time is 18 years. So we got to solve this equation here for R. So let's do that. Okay, so to solve for R, we need to divide both sides by the, well, let me do it the step-by-step way. This might make more sense. Let's just multiply the like terms here. So let me just go over here to decimal. 65,000 times 18. This might make more sense to people. There's a couple different ways you can do this, but you may need to show your work on this. But this is one way. So I have 235,000 is equal to these two multiplied together. So I multiply 65,000 times 18. I get this big number, right? And it's 1,170,000. So 1,170,000 times R. So now to solve for R, I got to divide both sides by 1,170,000. Okay, so here we go. So what is R equal to? I don't know. Let's figure it out. So 235,000 divided by 1,170,000. Got to make sure you type it in correctly. And we get this decimal here, 0.20085. So 0.20085. And if you shift this right two places, oh yeah. you get 20.085% as an interest rate. Wow. And by the way, that's kind of unheard of. You know, there's no bank on the planet that will give that kind of interest rate. So this is close to 20%. So in this example here, R would have to be around a 20% interest rate, which is quite remarkable and unbelievable. Okay, you just will not see that anywhere. No bank on the planet will do that because interest rates typically, especially a savings account, max out about 2-3%. Now, if you put this money in a stock market, you might be able to get 10-12%, but usually not 20 super high. No, I don't usually see that too often. Okay, unless you're doing a very, very risky investment where the interest rate is super high. All right, let's tackle another one. Dylan, number 5 here. Dylan has a bank account that pays 3.2% in simple interest. So I know that our 3.2% are 0.032. So always convert it to decimal first. His balance is $1,766. So that's the principal here, $1,766 right here. How long will it take for the account to grow to 2,000? So we want to go from 1,766 to 2,000. And the question is, how long will it take? T, that's T is equal to question mark. So this is a slightly different problem, but because we're trying to find the time and not the interest rate. So we need to figure out the difference from 1,766 to 2,000. So what would the interest have to be? So hang on. So how much interest would we need in order to get from 1,766? Sorry guys, let me just reformat this here. There we go. Okay. Sorry for the interruption right there. So what would that be? Okay, so interest, how much interest? Well, 2,000 minus the 1,766. What would that interest be? Probably do that in your head, but if not, kick in Desmos, right? So just whip that out and you get $234. So we need $234 in interest to go from 1,766 to 2,000. But how long will it take to do that? Well, let's figure it out. Okay, so this one was number 4 here. I'm just keeping track here. This one's number 5 down here. So again, write down your formula. I is equal to PRT. And then here I'm going to come down here and work this out. So let me see. So we need $234. The original amount right here is 1,766. That's your principal right there. I wrote that up here in problem number 5. All right, the interest rate is known. Interest rate is 3.2% or 0.032. All right, and we don't know the time. We got to find t. All right. All right, so here we go. Let's work it out. So let's multiply these two and get a number here and just simplify. So 234 is equal to something. So just simplify a little bit. Enter in 1,766 and multiply it by 0.032. So we get 56.512. 56.512 times t. Now divide by 56.512 on both sides. And you'll get t, the number of time and number of years. So here we go. So 234 divided by 56.512, and we get about 4.14 years. 4.14 years. So about 4 years. Okay, that's how long it will take. All right, so let's bring this over here. Number 5, approximately, t is approximately 4 years. So I guess we do need our spiral. We can't fit all this stuff in. Okay, dun dun dun. Number 6, let's continue. How long will it take? Okay, again, so it says how long, right? T is equal to question mark. How many years? I don't know. Will it take $5,000 to double all right, in the account that pays 1% simple interest. So we do know the interest rate is 1.6% or 0.016. All right, now if you want it to double, it's got to go from 5,000 to 10,000. So if you want it to double, the interest rate, or the interest, not the interest rate, has to be 5,000. The principal is 5,000. So we want it to we want it to double. So from 5,000 to 2,000 or 10,000. To make that happen, we need an interest of 5,000. Got to make it double, right? Okay, and we know the interest rate. We just got to figure out how long that will take. So again, I is equal to principal times rate times time. So 5,000 is equal to the original principal, which is 5,000, times the interest rate, 0.016, times t. We don't know how long that's going to take. So, first of all, you can just divide by 5,000 to simplify this thing. Let's do it the quick way here. And I get 1 is equal to 0.016t. So all I have to do is divide by 0.016, and I'm done. So let's do that over here. So 1 divided by 0.016, and notice I get 62.5 years. Okay? So t is equal to 62.5 years. All right, and that is number 6. All right, number 7. How much simple interest would a $1,500 earn in 11 months with an interest rate of 3.75 years? Okay, so I know R is 3, all right, 0.75, so 3.75%, so R is 0.0375 as a decimal. I know that. T is equal to, let me see, 11 months is not quite a year. It's a portion of the year. So you write T as 11/12 of a year. Remember, T is always in years. And the principal would be 1,500. So this is how much simple interest. So here we go. Let's just plug it in and go for it. So the simple interest is, the principal is 1,500 times the interest rate as a decimal, 0.0375, times 11/12 now. Because remember, the time has to be in years. And 11 months is, well, it's a fraction of a year, right? So you have to write it as a fraction of a year, 11 out of 12 months. And just type it all in. You're going to need a calculator in this course pretty much every day. All right? In finance, you just need it every day. So times 11 divided by 12, just type it in and boom. Desmos does everything for you. And then, so you get about $51.56. So $51.56 roughly. There's your interest. All right, number 8. How much simple interest would $1,000 earn in 275 days? So these two problems, 7 and 8, are related because in number 7, it dealt with 11 months, which is a fraction of a year. And here we deal with 275 days, which is also a fraction of a year. So here, the interest rate would be calculated as $1,000 times the interest rate. Now, 4.21% as a decimal is 0.0421. So I got to multiply it always by a decimal. Now times the fraction of a year. Now in this case, t is not equal to 275, okay? This is in days. It's a fraction of a year, so it's 275 out of 365. So make sure you write it as a fraction of a year. There's 365 days in every year, as you guys know. So go down here and type in 1,000, right, times 0.0421, right, times 275 divided by 365. There's your fraction of the year. All right, and you get about 31.72 rounded. So $31 it looks like, and 72 cents rounded. So make sure you round to the nearest hundredth. It says 0.719, but 0.719 cents is actually 72 cents. So always round to the nearest hundredth. Okay. Last one here that I'm going to do. Colin deposited $1,230 in an account that pays 2.19% interest for 3 years. So there's T, and there's R, and there's P. Right? This is P, we got R, we got T. So how much interest would be in 3 years? So here we go, first one first. Let's take $1,230, multiply it by your interest rate, 0.0219, times 3 years. Okay, and let's again do this in decimal. So 1,230, all right, times 0.0219 times 3. Okay, 80.81. So 80.81. There's your interest. What will the new balance be? Well, the new balance is equal to the interest that you earn plus the principal. So in this case, it's $80.81 plus the original principal of $1,230. So you take $1,230, your original principal, and then you add in the interest that you earned. Okay, they actually pay you interest, believe it or not, for lending them their money in their savings account, and you get $310.81. Okay, so you just learned a new idea here, and this one's right here. So highlight that. Balance is always interest plus principal over time, where you reverse that, principal plus interest. Same thing. So how much interest did the account earn in the first year? Well, let's figure that out. So in 1 year, so t equals 1 here, t equals 1. So you take $1,230, the principal, times the interest rate, 0.0219 times 1, because we're dealing with 1 year. So here we go, let's calculate it. So 1,230 times your interest rate, 0.0219, all right, times 1. You don't really have to put it in there, but just put it in there. What the heck? So $26.94. Okay, there's your interest. And then how much interest did it earn in the second year? Well, every year it's the same. So in the second year, t equals 1 again. So the interest rate is the same. Excuse me, the interest is the same. It doesn't say over 2 years, it says in the second year. So this is $26.94. And then in the third year, well, t equals 1, right? Because we're dealing with 1 year at a time, so the interest would be the same. And this is the case for every simple interest account. The amount that you earn per year, if left untouched, is going to be the same over time. Okay. I think that's it. So I'm going to stop here. That was quite a bit actually here. So if you guys need to listen to anything again, you've got an explanation for the first 9 in this lesson here in section 2.3 in financial algebra. So hopefully that helped you out. You guys work the rest on your own. Okay, and there's a second page here, 10, 11, all the way through 17. Okay, so this is on your own. And if you need help in class, okay, well, let me know. Also, remember to check answers in Canvas. So check answers results. You guys know that I publish the answers, so check your answers and results in Canvas. And then I will see you in my next lesson, okay, guys? Mrs. Aynesworth, have a good day. Take care. Bye-bye.